When nutritional science and drug addiction research collide, only here on the People Scientist podcast. You are listening to the People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Hello, my People Scientist Army, and welcome back to the People Scientist podcast for episode 154, where I aim to arm us with some scientific information so we can all become a little bit smarter and a little bit healthier with every new episode. How are you feeling today? I hope that you're feeling well. Thank you so much for inviting me into your day today. As many of you know, if you listened to last week's podcast episode, I'm currently in the middle of moving from New York City to Williamsburg to start a new position as an assistant professor at William and Mary. I'm so excited, and I can't wait to begin teaching and starting up my own research lab. So today's episode will be a little bit of a different one because as I'm recording this podcast episode right now, I currently have boxes everywhere in my apartment as I'm packing up. And I still wanted to hop on here and do an episode and create something for you. And it'll be easier for me to speak to something that is in my area of expertise. And I think that this topic is also very timely as well. So two of my areas of expertise are nutrition and neuroscience. And lately I have been studying addiction, like alcohol use disorder, nicotine, and opioid use disorder. You might be pondering, but what does nutrition have to do with drug addiction? But you see, that might just be the key. I approach drug addiction from this unique nutritional perspective, and I think it is unraveling a lot of very promising and unique approaches for drug addiction recovery. So I'm going to share some data from our lab and talk about related topics like how Ozempic, a common type 2 diabetes medication, may just help with drug addiction, and how that has hit the news recently this past month. So in today's episode, I'm going to speak about that and more. But as I always aim to do, I will try to make this episode relatable and actionable. But before we get into the core takeaways on that topic, as I always do, let me share a foregone fact, where I tell you a scientific finding from long ago. Mocked in the Journal of the American Medical Association all the way back in 1915, wrote of the history of opium. I love the way that scientists used to write over 100 years ago in their scientific publications. It was as though they were speaking to the reader directly, that they would describe their day and their journey of discovering science. It was so candid. And in a way, I really hope that scientific publications can go back and adopt that more personal style of writing again, because I personally really like it. So Mocked wrote back in 1915, quote, "If the entire materia medica at our disposal were limited to the choice and use of only one drug, I am sure that a great many, if not the majority of us, would choose opium. And I'm convinced that if we were to select, say, half a dozen of the most important drugs in the pharmacopoeia, we should all place opium in the first rank." Mocked wrote that the medicinal properties of poppy juice dated from a remote period, and yet not so far back in antiquity as we might expect, for the earliest definite and authentic references to it are found only in the Greek and Latin literatures. He had wrote that in 1915, their tincture of opium, or laudanum, as it was often referred to, dates back from the time of Paracelsus in 1490 to 1541. Paracelsus probably applied the name laudanum to several medicines, all of which had contained opium. One historian had described that laudanum consisted of 1/4 of its weight in opium, but it also contained henbane juice, mummy, salts of pearls and corals, bone of the heart of a stag, amber, musk, and essential oils. Laudanum back in 1915 was used to treat pain, insomnia, hysteria, and in very small doses to soothe crying babies. Today, over 100 years later, we can appreciate the extent to which this held a very high risk of overuse of an opioid and likely the development of addiction. I'm very proud of how far we've come in the last 100 years in realizing the risk of opioids, but I think we still have a long way to go. And that's what I'm going to talk about in today's episode. So without further ado, let's get into the core takeaways of today's episode. Today in episode 154, I talk about an area of expertise of mine, how I use my backing in nutrition to approach research on drug addiction. In my opinion, eating food, drinking alcohol, taking in drugs, that these are all consummatory behaviors. We are consuming a substance. Because we are consuming a substance that can have reinforcing feel-good effects. As such, eating and drug intake have some similarities in their neurobiology. In today's episode, I will also talk about a medication that has been in the news lately that is meant to treat type 2 diabetes that may have a role in treating drug addiction too. For example, I'm going to talk about a peptide called glucagon-like peptide 1, or commonly referred to or abbreviated as GLP-1. I will also talk about the potential of bitter compounds in the same light as well. So now, let's get into those scientific details. So as many of you know, I was originally trained in nutrition, and I transitioned to the field of behavioral neuroscience when I appreciated that our behavior is the greatest hurdle to our health. Because for the most part, I think we all appreciate how we can eat healthier. We know that we should eat fruits and vegetables and probably shouldn't eat several donuts every day, and we probably shouldn't drink 8 ounces of whiskey every day. But sometimes that happens. Why? Why is there a disconnect between what we know we should do and what we actually do? And that is what I study. So when I joined Paul Kenny's lab as a postdoctoral fellow, I began approaching the concept of addiction from a nutritional perspective. I proposed that whether we are consuming food, sugar, alcohol, nicotine, opioids, cocaine, that these are all consummatory behaviors that hold a lot of similarity. That we are consuming a substance that can have reinforcing or addictive qualities, and therefore the same neurobiological processes, the same brain regions, the same proteins might be all involved with these. And as the years went on, and as I collected more and more data, the data suggesting that yes, this is true. Now, in this episode, there are a few large concepts that I would love to share with you on this topic. The first is about a question that my interns had asked me last week. They had asked me what the difference was between dependence and addiction. Because a lot of the time, the goal that the physician is trying to achieve with someone who's battling with a substance use disorder is simply to have them move from the phase of addiction down to the phase of dependence. For example, we can see this when an individual is being prescribed methadone for an opioid use disorder. Because methadone is a partial agonist to the opioid receptors and can help reduce the craving for opioids like heroin or fentanyl or morphine. Now, the first phase of drug exposure or drug use is coined the experimental phase. And that might simply be when someone just tries a drug in a low dose for a couple of times to see how they feel, to see how they like it. Then the next phase, the second phase, is coined the recreational phase. This is when someone will use a substance like nicotine, alcohol, or other drugs when going out with others socially. That the substance is part of having fun or part of an activity, for example. The third phase is what we call dependence. And that is when an individual may feel like they cannot do things without having the substance. Like they cannot sleep without having a beer. They cannot sleep without having their pain medication, their opioid, that they cannot give a presentation in front of people without vaping, that they cannot study without using a stimulant drug, for example. That is the phase of dependence. And the phase of dependence in itself can be problematic, as it may interfere with someone's everyday living. It may interfere with someone's mood, especially if they have to be without the substance and they need to be able to cope with that. The last stage is coined addiction, and that is when the brain architecture has changed in such a way where the brain now thinks that it needs the drug to survive. For example, we can see connections between brain regions that are meant to act as these safety valves. The safety valve says, hey, I've had enough of this drug. I feel sick now. That's the aversive response, we call it. And the connection is the fasciculus retroflexus, which lies between the medial habenula and the intrapeduncular nucleus. And we see with long-term, for example, nicotine intake, that the fasciculus retroflexus becomes degenerated. That safety valve is lost. So as a result, more and more nicotine can be consumed. In this phase of addiction, we also see more risk-taking behavior. And here in this stage, again, the reason why is because the brain thinks it needs the drug to survive now. The brain architecture has changed in a way where behavior has now been significantly changed. So it is here where I'm going to make the second important point, which is that addiction should be considered a disease, much like heart disease or diabetes. And I think if we can consider addiction in this vein, then treatment can improve. That stigma can be broken. It is also important to note that yes, addiction has a genetic component. We know this. Some people may be born with a higher disposition for developing an addiction if they are ever exposed to a drug. For example, let's talk about the gene CHRNA5, which represents a subunit of a nicotinic acetylcholine receptor. Individuals that are born with specific genetic alleles for this gene, meaning slight variations in their genetic code for this gene, seem to have less of an aversive response to high doses of nicotine. So they can take in very high quantities of nicotine and they don't feel nauseous. They don't feel ill. They don't have that aversive response. So as a result, individuals with this genetic allele are far more likely to be a heavy user of nicotine if they're ever exposed to nicotine. We are seeing connections of genetic alleles with opioid use disorder as well. So an individual may take an opioid or a pain medication when they undergo surgery, and they may be more likely to develop a dependence or an addiction on the opioid more quickly than another individual because of their genetic makeup. A third important message that I'd love to share with everyone is the terminology that we use for addiction. We tend to now use more so the term substance use disorder, like alcohol use disorder or opioid use disorder. And the reason why this terminology is being more and more adopted is because this phrasing allows us to appreciate that individuals battling with substance use disorder are using the substance for a reason. Substance use disorder, they're using the substance for a reason, meaning they likely started out using that substance to treat their pain. They maybe have been using the substance to treat depression or mental health condition. And eventually, perhaps they needed more of that substance to treat the pain, more of that substance to make themselves feel better. Self-medication in a way that over time, though, over this repeated use, that the brain's architecture changed, driving the individual to now go into the phase of addiction. So the term use disorder is helpful in us creating empathy and understanding that many have used a substance to try to cope with the pain that they are experiencing. And unfortunately, that turned into an addiction. So the reason why I bring up this topic for today's episode is because as of late, there is much attention being placed on a medication called semaglutide, or the brand name Ozempic. This medication works by being an agonist or activating the glucagon-like peptide 1 receptor, which is abbreviated the GLP-1 receptor. When the GLP-1 receptor is stimulated or agonized, it stimulates insulin release in a glucose-dependent manner to help individuals regulate their blood sugar levels. So the clinical trial data on GLP-1 agonists like semaglutide are primarily based on blood glucose regulation. But interestingly, physicians and individuals who use semaglutide are noticing other effects, such as reduced food cravings, some weight loss, and anecdotally, some individuals report not craving alcohol or nicotine as much anymore. Now, there are not any clinical trials to see if semaglutide can treat disordered eating, reduce eating, or drug addiction, but there is preclinical data coming from our lab, led by Paul Kenny at Mount Sinai, that suggests this very much could be the case. So GLP-1 or glucagon-like peptide 1 is known to induce the feeling of satiety, the feeling of satisfaction, saying, hey, I feel satisfied, I've had enough. Now, from our lab, Louis Tuesta and others published in the journal Nature Neuroscience in 2017, how this peptide GLP-1 can act in a specific brain region called the medial habenula to lower nicotine intake. So if GLP-1 receptors are activated, it appears to reduce nicotine craving and it reduces nicotine intake. Similarly, in a study led by one of my best friends, Alex Duncan, in which I was also a co-first author on the paper, we published a study in Nature in 2019 showing another GLP-1 agonist, Exendin 4, was able to reduce nicotine intake, and that this was dependent upon another protein called TCF7L2. Now, to help explain this neurobiology a little bit, let me give an analogy. Have you ever been in your kitchen and you have a pot of boiling water on the stove? Let's say you're cooking something, like you are cooking pasta or oatmeal in that boiling water. And the water starts to bubble up, and it looks like it might overspill the top of the pot. But then you do the trick where you put the wooden spoon across the top of the pot, and now the bubbles seem to calm down a bit, and they won't spill over the sides of the pot. Well, GLP-1 is like the wooden spoon. It says, hey, you've had enough. It's time to stop. It's time to calm down. It's time to stop consuming whatever substance you're consuming. It is therefore called a satiety peptide. And because we are drawing similarities among food intake and drug intake, medications that stimulate GLP-1 may help curb craving and appetite for both food and drugs. However, we need to study this in clinical trials, and that finding is limited to preclinical data. But in the meantime, what we know is that there are certain things that can help stimulate the release of GLP-1 naturally. And some of my own research projects focus upon this concept of GLP-1 and how bitter taste receptors are involved in drug addiction as well. Bitter compounds release GLP-1 to stimulate the neurobiological signal of satisfaction and satiety. Now, the reason why we think bitter compounds do this is because bitter compounds in nature tended to be associated with poisonous plants. And so when we taste something that is very bitter, our brain says, hey, this could be harmful. I'm going to send this signal for you to reduce your appetite and your cravings, that you stop consuming this thing that could potentially be harmful. The fascinating thing is that the grand majority of addictive drugs are classified as bitter alkaloids. So you name it: caffeine, cocaine, morphine, methamphetamine, fentanyl, heroin, oxycodone, they're all bitter alkaloids. So bitter things can act on the same brain regions as some addictive drugs do. They're in the same vein. This includes my favorite brain region, the nucleus of the tractus solitarius, that expresses glucagon-like 1 peptide receptors, that is responsible for that feeling of satisfaction and satiety, that reduces craving. Bitter things also tend to increase gastrointestinal motility, and that's thought to do that to help remove the substance from the body. The brain is saying, hey, this could be harmful. Let's try to remove it from the body. This is how colon cleanses on the market primarily work. They're oftentimes a combination of very bitter plants that are working on this same systemic system. But the thing is, today in our food market, we know that bitter foods we consume are not harmful. And the reality is that they may still provide that satiating effect, that satisfying effect via the same neurobiological pathways. So my goal is to elucidate the role of bitter taste receptors in drug addiction and to understand how we can use that information to create new therapies to promote recovery from drug addiction, to reduce drug craving, to reduce drug relapse. Unfortunately, I cannot get into the details of this project until it is published. But what I can say is that the data is very promising there as well, and I'm looking forward to publishing that and sharing all the data with you one day soon. So that is a wrap, my People Scientist Army. A shorter episode today as I pack and transition to my new position as a professor starting at my own lab. But I hope that this episode was insightful and interesting for you. We see common threads in behaviors involving the intake of food, sugar, alcohol, nicotine, and drugs like opioids and cocaine. They are driven by a desire for more. And in this episode, I distinguish between dependence and addiction, where dependence involves needing a substance for things like sleep, and addiction reshapes the brain for the brain to believe that the drug is necessary for survival. And that can involve driving risk-taking behavior. I also advocate using the term substance use disorder to reflect how substance use can start for things like pain relief or mental health betterment, and that unfortunately it can evolve into addiction. I spotlighted the diabetes medication semaglutide, which has shown unexpected effects like reducing food cravings and aiding weight loss. The medication's impact on a brain area linked to nicotine reduction is promising for addiction treatment too. And me personally, I'm currently exploring the connection between bitter taste receptors and substance use disorder, and I hope to generate new treatment strategies from this new perspective, this nutritional perspective on drug addiction. So thank you for tuning in. It means a lot to me that there are many loyal listeners that tune in with every episode. I know that you're there, I know that you're listening, and I often think of you and thank you for tuning in with me and hanging out with me every 2 weeks. If you want to hear more about this podcast topic, to see the papers I cite, then you can follow me on social media. My handles are in the description box to this episode. As you know, I do not use ads in this show because I want to remain as unbiased and uninterrupted as possible. So if you want to support the show to say, hey, thank you for the episode, you can buy me a coffee, and the links on how to do that are in the description box to this episode too. I hope that you all have a wonderful week, and I look forward to meeting you all back here for episode 155. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.